Hey everyone, and welcome to our very first lesson in this comprehensive course on high-pressure die casting of aluminum alloys and Zamic. I'm really excited to kick things off today with an introduction to what high-pressure die casting, or HPDC, is all about. You're going to learn why this process is so vital in modern manufacturing. So, what exactly is high-pressure die casting? Well, imagine taking molten metal. We're talking super hot, liquid metal, and then forcing it under incredible pressure into a precision-made metal mold. This mold is what we call a die. Once that metal cools down and solidifies, the die opens up and out pops a perfectly formed part. That's HPDC in a nutshell. High pressure, molten metal, and a reusable die to make parts with amazing surface quality, super tight dimensions, and really intricate shapes, all at lightning-fast speeds. Now, this isn't a new invention. Die casting actually goes way back to the mid-19th century, starting with making things like printing type. But it really took off in the early 1900s, driven by industries like automotive and consumer goods, which needed tons of identical parts quickly and cheaply. Fast forward to today, and thanks to better materials and machines, we have the advanced HPDC process we're focusing on in this course. Let's quickly walk through the key steps. First, the two halves of our steel die are prepared, cleaned, lubricated, and clamped shut. Then, molten metal, usually aluminum or zinc alloys, gets poured into what's called a shot sleeve. A powerful ram then slams that molten metal into the die cavity under pressures that can be as high as 25,000 pounds per square inch. It's an intense process. The metal then cools and solidifies super fast, thanks to the cool steel die. Once solid, the die opens and ejector pins gently push out your brand new casting. Finally, we trim off any excess metal, like flash or runners, and you have your finished part. So, why do we use HPDC? The benefits are huge. We're talking about extremely high production rates, thousands of parts an hour. You get an absolutely fantastic surface finish, often so smooth you don't need any extra work. The parts are incredibly accurate dimensionally, meaning less or no machining needed afterwards. HPDC also lets you create really complex, thin-walled shapes. And while the initial setup and tooling can be costly, for high-volume production, the cost per part becomes incredibly low. Plus, that rapid cooling gives the parts great strength. In this course, we'll primarily focus on two material families: aluminum alloys, loved for their strength-to-weight ratio and use in everything from car parts to electronics, and Zamic, which are zinc alloys known for their amazing castability, strength, and beautiful surface finish, perfect for intricate, smaller components. You'll find HPDC parts everywhere, under the hood of your car and your smartphone, in household appliances, and even in some aerospace components. It's truly a cornerstone of modern manufacturing. By the end of this lesson, you should have a solid grasp of what HPDC is, how it works, its history, why it's so beneficial, and where you'll find its products. This introduction is just the beginning. In our upcoming lessons, we're going to dive much deeper into the machinery, the tooling, and the fascinating metallurgy that makes HPDC so powerful. Stay tuned, and let's keep learning.